Hey, jackass, where's my DoorDash?
I don't know. DoorDash had a problem. As their cloud-native environment scaled and developers delivered new features, their monitoring system did what monitoring systems do and kept breaking down. In an organization where data is used to make better decisions about technology and about the business, losing observability means the entire company loses their competitive edge. With Chronosphere, DoorDash is no longer losing visibility into their application suite. What's the key? Chronosphere is an open-source, compatible, scalable, and reliable observability solution that gives the observability lead at DoorDash business confidence and peace of mind. To learn more, read the full success story at snark.cloud/Chronosphere success. It's a pattern that's haunted me for my entire career. And it starts like this. Step 1, encounter technical problem. Step 2, search in vain for an answer. Step 3, lose all hope. I once again stumbled through this depressing sequence while puttering around with my last tweet in AWS Twitter shitposting client. So please join me on a little journey through this particular painful experience. Now, if you haven't heard of it before, Last Tweet in AWS.com is a free-to-use Twitter client that makes creating threads easier while also providing passable image recognition and OCR to create alt text for images. It's built on top of AWS's serverless technologies with some help from Azure, and it's served from 20 AWS regions, depending on which of them is closest to the user. Because it uses AWS's API Gateway v2 or HTTP APIs, it can only listen on port 443 via TLS. That is, that service will not listen for unencrypted traffic on port 80. This is fine because I don't want people sending sensitive information around in plain text. The problem that I run into is when I forget to explicitly put the HTTPS in front of the domain. Then a service such as, amusingly enough, Twitter, attempts to direct people who click on that link to port 80 instead. So when this happens, the connection attempt fails, and it looks for everyone as if there's no website there at the domain in question. Now, there isn't a great answer for this that doesn't dramatically overcomplicate things. AWS's official position is to just put CloudFront in front of the API gateway. Great. Genius plan. That would mean that I would need to then either configure 20 origins for the CloudFront distribution and find some way to get them to pick the closest one to the end user, or else undo all the benefits of having a multi-region setup in the first place. Plus, every request of this thing's dynamic, so there's no caching story that makes a lick of sense. This was the state of things when I found the one answer that at least somewhat mitigates the concern. See, back in 2012, a standard was released called the HTTP Strict Transport Security Standard. While it is fairly complicated, because let's not forget, this is the internet, it states that a website can return a header with the name Strict Transport Security that then specifies a length of time. Browsers, when they see that header, will remember it, and for the length of that time, will refuse to even attempt to connect to that domain over an unsecured connection. Well, that works super well for the folks who visited the site before. A combination of my traffic analysis, a careful counting of the number of commas in my AWS bill, and some basic arithmetic all point out that way more people have not visited last week in AWS.com than have. So what good does setting a header like this do for the overwhelming majority of the internet's population who has not been exposed to this particular brand of my nonsense? And this is where the HSTS preload list comes into play. This is a list of domains that return the proper header that gets loaded into all of the major web browsers. Once a domain is added to this list and that list gets circulated to all the providers, this problem gets solved for basically everyone, since all the browsers will then fail to even attempt to connect on port 80, although getting this circulated and implemented does take months. Now, my problem, and the reason that led to this video, was trying to figure out how to set that specific static header on the v2 HTTP API. Now, a few things colluded here to make this a very hard thing to search for online. API gateway is a very common term. HTTP API is such a common term across so many different areas of the internet, you can basically discount that as being impossible to search for. It's like the word the. Most combinations of search terms that I tried, both on Google and begrudgingly on AWS's own documentation search dingus, all led me, sometimes directly and sometimes via third-party blog posts, to the same narrow subset of search results. Now, I'm no $1.434 trillion company, but it does seem to me that if you're running any form of analytics on your documentation traffic, and you see the same user showing up to the same page repeatedly over the course of an hour, coming from a bunch of different paths, perhaps this might be signal that they're looking for something and they're just not finding it. Now, I hate pop-ups when I'm trying to get something done, but the fifth time that I'm staring at the same page, wondering what it is that I'm not understanding or not seeing, that would be a great time for the documentation to offer to help me more effectively. I finally found the answer via a carefully constructed search for code on GitHub, which shouldn't have been necessary, but absolutely worked out for me in the end. For the record, if somehow you're trying to solve this problem and stumble across this video, the answer to the question is whenever something is returning data to the API gateway, just have it insert an arbitrary header into the JSON response, and the API gateway v2 will just pass it through to the browser without comment. But that was basically impossible to discover, and it didn't work in previous incantations. So to do that, I solved that, and then everything worked. But here's the larger problem this leads to. When we're faced with a technical challenge, how do I do this is the burning question that consumes us until we get an answer, in most cases. We search and we plumb the depths of forum threads that haven't been updated in a decade, and all in pursuit of the magic answer that sorts us out. It eludes us, it drives us slowly mad, and then we figure it out. Because it turns out there are 5 steps to this harrowing pattern for developers. Step 1, encounter a technical problem. Step 2, search in vain for an answer. Step 3, lose all hope. Step 4 is eventually discover an answer, ideally. And step 5 is don't bother to publish the answer for the next sucker. And here's the problem. None of us goes back to all of those dead ends to update these long forgotten forum posts. We don't return to Stack Overflow and update old questions just so they can get closed as off topic anyway. We don't hit the surprisingly effective feedback link at the bottom of every AWS documentation page. And this is the real problem I don't have an answer for, not the static header. And this has haunted me for my entire career. If you have an idea on how to solve this, and it doesn't involve me paying some sketchy startup of yours a pile of money for unclear value, please reach out and share it with me. Because if not, then every time I wind up stumbling through a problem like this and finding an answer, you can expect another video just like this one. So the next poor sot who tries to do something like setting this nonsense up for a header can find the answer easily. Ideally, without having to read through or listen to the rest of my nonsense.